Okay, class, in this lesson, we are going to learn to do one of the followings, actually four of the followings. We're going to compute the range of a set of data. We're also going to compute the mean deviation for that same set of data, as well as its variance, and then ultimately the standard deviation. Now, I want to preface by saying that the mean deviation, the variance, both of those are going to lead to the calculation of standard deviation. I know that there are tools today that will automatically calculate standard deviation for you. However, I believe that it is important to understand how that is derived. And so we're going to go through some exercises to help us to get to that point. All right, so let's go ahead and get started. So the thing to recognize is that when we talk about the dispersion of data, okay, that's really the spread, or one of the measures of dispersion or spread of data is called the range. And the range is essentially taking the highest value, subtracting the lowest value to give you the range. So it kind of gives you that spread. You know, if you've got a set of data, it helps you to understand, well, how high does a number go and how high does a number, or how low does a number go? Okay, so let's go ahead and take a look at this particular example. So Mr. Smith's video production club has 10 students in it, and members were asked how many movies they streamed last year. Okay, how many movies each of them streamed last year? And the 10 students reported the following numbers. Okay, and the question here is, what is the range? All right, so the range is going to be the highest value. So I'm going to say range is equal to the highest value minus the lowest value. Okay, and so if we take a look at these 10 data points, we see that the largest number here is 41. Okay, so we're going to say that our range is equal to 41 minus, let's take a look at this again, the lowest value here is 9. So it's going to be 41 minus 9. And that works out to 32. Okay, so that is our range of data. So that kind of gives you an idea of a dispersion, okay, or the spread of the data, but that's not the only measure for dispersion. Okay, so let's take a look at the next example. Here we've got one of the video production club members, Maria. Okay, so this example is related to the previous example. The member noticed that the range seemed to ignore all the numbers except the highest and lowest, which is true, right? We ignored all the other values. So we want to know what's going on with those data points as well. So she thought a better measure of dispersion would be to take an average of how far each number is from the mean, okay, which is called the mean deviation. All right, so the question here is, how far on average is each entry in the data set from example 1 from the mean of the distribution? Now, what exactly is going on here? So what I've done here is drawn a number line and just kind of put down some points. All this data comes from the previous example, okay? And we can kind of see that the average, right, the middle is somewhere right around here, okay? So we want to know, when we talk about the mean deviation, we want to know how far from the average is each of these points, okay? So 9 is about this distance, 15 is about this distance, 16 is about that distance, and so on and so forth. And we do the same thing on the other side, okay? So we want to find what that distance is, and then we're going to find the average of that, okay? So the best way to do this is to use the spreadsheet. So let's go ahead to the spreadsheet. Okay, so here I've got all of the data listed in the chart. And so what I'm going to do in column C is just take each of the points and subtract the average. But before we do that, we need to find the average. So on cell B13, I'm going to go ahead and calculate that. And there's a function called average. And I'm just going to take the average of all of these values. Okay, that's the beauty of the spreadsheet. It helps you to get those numbers very quickly. All right, so we now know that the average is 23. So now we're going to take each of these cells and I'm going to subtract the actual value, so column B, cell 3, and I'm going to subtract the average, which is B13. Okay, and now I'm going to go ahead and just lock these in by using this dollar sign so it doesn't move. And now we're going to go ahead and copy the cell all the way down column C. Okay, and then we're going to take the average of this entire column. Okay, we've already done the average of column B in cell B13. I'm going to just go ahead and copy and paste this over. And we see that the average is 0. That's odd. Why is that 0? Well, the reason that's 0 is because we have negative values in column C, right? So if you take a look at cell C4, C5, C8, C9, and C11, they all have negative values, okay? So those negative values offset all of the other positive values, okay? Now when you're taking the average, let's go back to our notes here. When you're taking the average, I'm going to go ahead and just note this, right? So we said 23 was our average, okay? And we notice the distance for each of these points from 23. When you take that average of all of these, it naturally will work out to 0 because the negatives offset the positives and the positives offset the negatives. And since we're taking the average of those distances, this means that the average is exactly 23. So that 0 value that we just calculated means that that average is exactly 23. Okay, so then how do statisticians resolve this? Okay, before we go on, let's just go ahead and write that the answer to this question is 0. Okay, how far on average is each entry in the data set from example 1 from the mean of the distribution? Okay, so how far away is it on average? It's not far away at all. It's exactly on 23. So that was the point I was trying to make. Okay, so how do statisticians resolve this? Let's go ahead and go to the next example. So what they do is they find the variance of a data set. Okay, so what we're going to do is go back to the spreadsheet. Okay, we're going to take that mean deviation, and instead of just taking that value, we're going to square them and then take the average of that. And that will essentially be our variance. Okay, so let's go to that spreadsheet. So we're going to take cell or column C, and we're going to square each of those values. Okay, so we're going to go ahead and say equals, and we're going to take the value of cell C3, and we're going to square it. And that square symbol is that caret sign that's above the number 6 on your keyboard. Okay, and then we're going to follow it with a 2 that tells the spreadsheet we're going to square it. All right, so obviously 9 squared is 81, and we're going to go ahead and copy and paste the rest of these cells. And as you can see, the square of -5 is 25, the square of -8 is 64, and so forth. Okay, so now we're going to take the average of that column, and that works out to 76.6. Okay, so the average is 76.6. So we're going to say that the variance is equal to 76.6. Okay, now that number in it by itself doesn't really give us the answer, or doesn't really tell us what we need, because if you remember taking a look at the spreadsheet, all of these values in column D are squared, right? So if we are looking at a unit measure of, let's say, inches, then column D would be inches squared. Or if we're looking at a unit measure of feet or yards, then column D would be feet squared or yards squared. So that doesn't really make sense, okay? So then let's take a look at this next example. We then move to what's called the standard deviation. And the standard deviation is really equal to the square root of the variance, okay? So we're moving it back to the unit measure. So as I said earlier, if we have inches squared, variance is inches squared, but we want it to be inches, so we're going to take the square root of inches squared, and we end up with inches, okay? So if we take the variance that we calculated, and that was 76.6, we find that that value, or standard deviation, is now 8.8. Okay, 8.8. So that is how you calculate standard deviation. So what does that mean? Let's go back to the number line that I created. The standard deviation tells us that on average, okay, or it kind of tells us the spread or dispersion of this data for the majority of the data, okay? So from the mean of 23, if we go to 8.8, let me draw it this way. If we subtract 8.8 from 23, that's about 14. Okay. I went a little too far here. Okay. So down to about here. And then if we add 8.8, that takes us to about here. Okay, so we'd see that that standard distribution takes into account all of the data with the exception of what we would call the outlier, which is 9 and 14. It's kind of like on the outer range, okay? So the standard deviation tells us what's really going on with all the other data points in the data set. Okay, so hopefully that made sense to you. Ultimately, what we were trying to do is get to standard deviation. And if we take a look at the spreadsheet, as you can see, we get to the standard deviation by taking the data values in column B, we're taking the mean deviation in column C, we're squaring them and taking the average to find the variance, which is noted in column D and specifically in cell D13, and then taking the square root of that number to get our standard deviation, okay? So that is I hope a simple process to go through to calculate standard deviation, and hopefully that made sense to you. If any of this was confusing, please go back to the beginning of the recording and listen to this again. Thank you.